Hi, hello everyone. Welcome to day two of solving random NECO question from NECO 2026 chemistry examination that was written this year. So this is day two. Now let's take a random question from the theory part. And the question is under electrolysis, but it deals with a little bit of stoichiometry. And let's read the question. The question reads, calculate the volume in dm cube of hydrogen gas produced at STP during the electrolysis of dilute sulfuric acid if 1.0 ampere was used in 15 minutes. The volume of hydrogen gas produced at STP. Now let's quickly write that down. Our main aim here is to calculate the volume of hydrogen gas. Remember, it will be at STP. And we know that at STP, the volume, 1 mole of any gas will be equal to 22.4 dm cube. That's a constant we learned in stoichiometry, right? Now, what other parameters are we given? We are given the time to be equal to 15 minutes. Remember, while calculating for Faraday's calculation, we have to convert minutes to seconds by multiplying by 60, and this gives us 900 seconds, right? We also give them the current to be equal to 1.0 ampere. Now, what do we simply do? Remember that 1 mole of any gas is equal to 22.4 dm cube. Now, we can use the Faraday's calculation to say, okay, if the mole is Y, the volume will be equal to X. We have arrived at the answer. The aim is to calculate for the volume. But we know that if we can use Faraday's calculation to get the mole of that hydrogen gas that will be liberated, then we can equate it here to get our value for volume, which is X. Now, let's dive into that. Don't be confused. Let's solve that. One formula from Faraday's formula says that mole is equal to current times time all over charge times Faraday's constant. The current is this 1.0, the time is 900 seconds. The charge of in hydrogen gas is 1. Hydrogen ion is 1. So the charge is going to be 1. And our Faraday's constant, 96500 coulombs. So let's quickly plug that. We want to calculate for mole. Our charge is 1 times our time is 900 all over. Our charge here is 1, which is in hydrogen gas. Hydrogen gas has just 1 charge times our Faraday's constant 96500. So in order to solve for the mole, we divide that 900 divide 96500. That simply gives us 9.326 exponential 3 exponential minus 3 mole of that hydrogen ion. But remember that in electrolysis calculation, 2 mole of hydrogen ion will produce just 1 mole of hydrogen gas. So the ratio here is 2:1. So whatever value we get for the mole of this, we have to divide it by 2 in order to equate with that of the hydrogen gas produced. So we simply say the mole of hydrogen gas will be equal to the mole we calculated here, exponential 3, divided by 2, because the ratio of the ion to the gas is 2:1. So when we do that, we will simply divide that, divided by 2. We are going to get 4.663 exponential minus 3 mole. Now, this is the mole of the hydrogen gas that will be liberated. Now, let's go back to our formula. At STP, 1 mole of any gas is equal to 22.4 dm cube. Now, the mole of the hydrogen gas that we produce in this electrolysis is no longer Y. It is now 4.663 exponential minus 2 minus 3 will give us how many dmq. So we cross multiply this, and our final answer will be the volume of hydrogen gas will be this value times 22.4 dmq, 22.4. That gives us 0.105 dmq. So that's the value at dmq. So the electrolysis, we produce hydrogen gas of 0.105 dmq. Can we convert this to cm cube? Can somebody give me the answer in cm cube in the comment section? Have a nice day and see you in the next time.